Hi everyone, I'm Daria from Subsquid, and today I will show you how to index swap transactions on Uniswap. So first, let's make sure that we have all the prerequisites. For this project, we need Node, Squid CLI, and Docker. After making sure you have Node and Docker installed, you can install the Squid CLI. For this, you need to run the following command in your terminal. I already have it installed, so I will start the project. For this, we can use the simple EVM template. So let's run sqd init, then the name of the squid. So I'm going to name it swaps v3 squid -- template EVM. And let's cd into the folder. And run npm ci, and that will install all the dependencies for us. After dependencies have been installed, we can open the project in VS Code. So first, let's start from the schema. We are going to index swaps and pools. So let's get rid of all of this. And first, define the pool entity. Let's go type pool entity, and it's going to have an ID, token 0, and token 1. And it's also going to keep track of all the swaps in the pool, so we can define it this way. Swaps is going to be an array of swaps, and it's going to be derived from the field pool in the swaps entity. Now let's define the swap entity. It is also going to have the ID. We also need to keep track of the block number, the timestamp, and timestamp is going to be of type date time. We would also want to keep track of the transaction hash and the pool. And we also want to keep track of the amount 0, which is going to be a big integer, amount 1, which is also a big int, sender, which is a string, and the recipient. And here's our schema. Since we are tracking swaps, you might have a question why we need also to track the pools. And we are going to use the pools to verify that the swap event has been emitted by a pool, and that we are not just indexing a random swap event. Next, let's run the code gen to generate the typings from our schema. For that, we run sqd code gen. Since we're indexing events of particular contracts, we also need their ABIs. You can follow the link below the video and copy the ABIs for pool and factor. And let's paste them into the ABI folder. Now that we also have our ABIs, we can run sqd type gen. This will generate the typings from the ABI so that we can import events and functions and use them to index the contract. Now let's go to the processor.ts file. Here we define the data sources for our indexer. So let's get rid of all of the comments. We don't need them anymore. We also don't need the transaction to the 0 address. We can leave the block range for now. Next, let's add the logs. So we want to index pull created event, we can edit the following way. Add log address, and the address is going to be the factory address of the Uniswap. You can also copy it below, and let's put it into a constant. So our address for the log is going to be factory address. Now let's import our ABIs. So first let's import the pool ABI. And let's also import the factory ABI. So now we can use the ABIs to index particular events. Let's go back here and add a topic. So this way we're specifying that we're only interested in events with topic 0 equal to pool created. Next, let's add the log for the swap. We don't have a particular address because we want to index all of the pools, so we only add the topic. And we also need to add transaction true, so that the transaction is also included in the log. Now let's set the fields. So from the transaction, we only need the hash, and for log, we need both data and topic. So we set both to true. And also let's change the block range. Since the factory has been deployed around 12 million, we can skip the blocks before that, because they're not going to have any events anyway. And finally, let's export another type, which is called context, so that we can later pass it when we want to work with database in our functions. So let's go export, type, context, and it's going to be equal to data handler context. And we import the store for this. So now that we are done with the processor, we can go to main file and actually process and index the data. So first, let's delete everything here because we don't need it anymore. Now let's import our entities from the schema. So we have swap and pool. Let's also import the ABIs because we will need it to filter the events. Let's also import this in function from the typeworm. We will need it later, so it's more convenient to import now. Now let's import the types from the processor. And finally, let's import assert not null. We will need it later as well. So now we are ready to start. To index all of the swaps, we need to go through every block and through every log and detect the events we're interested in. We also need to keep track of the pools so that we can verify our swaps. To keep track of the pools, let's create a set. Let factory pools equal new set. Now we start to process the data. First, we need to check if we have already saved any pools into our database. So to do this, let's first check if our set is undefined. So if our factory pool set is not defined, then we go and retrieve the pools from the database. We want to retrieve every pool entity without any parameters. Then we want to create a new set and populate it with their addresses. So we go new set pools.map, and we match each pool to their address. And in this case, it is pool ID attribute. Now our set will contain all of the addresses of the pools we have previously seen. And later we will use it to index the swaps and verify the log addresses. Now for our convenience, let's define two new interfaces. So first is going to be pool interface. We're going to call it pool data, and it's going to have an ID, which is a string, token 0, and token 1. Next, let's define the swap interface. It's also going to have an ID. We also want to keep track of the block, and it's going to be a type block, transaction, pool, which is going to be address of the pool, so it's a string, and then amount 0, which is a big integer, amount 1 as well, recipient address, and sender. Now that we have created the interfaces, let's create two empty arrays where we are going to keep the data. So first one is going to be let swaps, and it's going to be of type swap data array, and the other one is going to be pools of type pool data. And let's rename them swaps data and pools data. It's also going to be an empty array. Start iterating over the blocks. So let's create a for loop for let block of blocks, and it's going to be ctx.blocks. And next for let log of block.log, and this is our loop for processing the logs. So since we're indexing two types of events, we're going to want to differentiate between them. We can do this by comparing their topic 0 to the topic of the swap and pool created logs. So if log.topics 0 equals to factory ABI dot events dot pool created dot topic and log address is equal to factory address. Then we know that we get a pool created log. So we want to do something, process data. Otherwise, if log dot topics at 0 equals pool ABI dot events dot swap topic and factory pools has the log address, which means that we have already indexed the pool that emitted this swap event. Then we process swap data. First, let's retrieve the pool data from the event. So for this, we're going to implement a helper function. Function get pool data, and it's going to take our log, and it's going to return pool data. We can destructure the event. So it's going to be let event equal to factory ABI dot events dot pool created decode log. Now we can see that we got the event and has token 0, token 1, feed, tick spacing, and pool. We only need 3 of those. So we can return ID, which is going to be event dot pool, and let's also make it lowercase. Then we need token 0, which is going to be event.token0 also to lowercase, and token 1. And like this, we have the pool data. Next, let's process the swap data. To process swap data, we also need transaction hash. So let's define transaction. Let transaction equal to log.transaction. And let's take a look at the type of the transaction. We can see that it can be of type like this, have ID, transaction index, and everything else, or it can be undefined. But if the transaction is undefined, we cannot process the swap. So here we're going to use assert not null to make sure that transaction is always defined. And if it's undefined, we can say log swap log without transaction. Next, let's decode the event. Again, we do a let event equal to pool ABI dot events dot swap decode log. And we can see that the event has everything that we need. So we can return ID is going to be log.id. Next we have block. We can retrieve it from the log. So log.block. We can also have the transaction, the pool, which is the address of the log, amount 0. We can also get it from the event, amount 1. Recipient, let's also make it lowercase, and the same for sender. So now we have successfully fetched the data for the swap. Let's go back up, and here we can say let pool data equal to get pool data log. Next, let's define the swap data. So we can do the same, let swap data equal to get swap data.log. So we're almost done. Now we need to process pool data and create pool entity from it, and the same for the swap data. Let's add our pool data to the arrays that we created so that later we can batch process them and write to the database. So it's going to be pools data.push pool data and swaps data push swap data. Now we need to take the array of pool data and swap data, create entities, and insert them into the database. So let's go here and define a new helper function. This function is going to be asynchronous since we're going to be working with the database. So async function save pools. It's going to take ctx, which is context, and pool data array. So pools data going to be the array of pool data. Need that. Next, let's create an array of entities. Let pools, which is pool array, equal to empty array. Now for each pool data, we want to go and create a pool entity. So let data of pools data let pool equal to new pool, where ID is data ID, token 0 is data.token0, and token 1 is data.token1. And we need to add curly braces around. Now let's push the pool into the array of pool entities. And also, let's add the address of the pool to our factory pools set. So factory pools dot add data.id. So like this, we have recorded a new pool that we indexed. Now let's create the same function for the swaps. It's also going to be asynchronous. Sync function save swaps context and swaps data is going to be there of swap data. Here, let's create a new set of pool IDs. We needed to keep track of the pools that we have encountered while indexing swap data. And let's populate it with our pool IDs. So for let pool of data swaps data pool IDs add pool dot pool. Actually, let's rename it. So let data of swaps data, and then pool IDs data dot pool, so it's not confusing. Now let's retrieve the pool entities from the database using this array. So let pools equal to await context.store.find by, and we want every pool entity where the address is in the pool ID, so we do it like this. ID, and now we use the in function we have imported earlier. And this retrieves all of the pools that satisfy this criteria. Now let's map them to their addresses. So let pool map equal to pools. Actually, it's going to be of type map, where string is going to be mapped to a pool, equal to new map, where pools dot map, and then we want to map each pool to its pool ID, like this. Let's also create the swap array. So let swaps equal to empty array of swap entities. Now we can go through the data and fetch the swaps. Then we will add them to this array and write them into the database. So for let data of swap.data, swaps data, let ID block transaction pool amount 0, amount 1, sender and recipient equal to data. So like this we can destructure the data and fetch each of the values separately. Now we need to make sure that the pool that emitted the swap event exists in our pool map. So let pool entity equal to pool map dot get pool, and we also need to use assert not null, because we can't work with the null value. Now we can create a new swap. So let swap equal to new swap, and ID is going to be ID. Then we have block number, we can get it from block.height. Then the timestamp, we can get it from block timestamp, and we need to convert it into a date. So new date, and pass the block timestamp. Next hash, we can get it from the transaction. Pool is going to be the pool entity. Then sender, recipient, amount 0, and amount 1. We can just do it like this since the names are aligned. Now all we have to do is to push the swap into the array of swaps. So swaps dot push swap. And finally, in the end, we need to write the swaps to the store. So await ctx.store save swaps. And actually, we forgot to do this in pools, so let's add it here as well. And now we just need to call these two functions. We do this after processing all of the blocks. So await, save pools, and await, save swaps. So like this, we're done. Now let's recap what we did. So first, we created a set of factory pools to keep track of the pools that we have seen. Then we created 2 interfaces, which we used to organize our data more conveniently. Next, we went in and also fetched all of the pools we have previously saved into the database and retrieved their IDs. Then, going block by block and indexing each log, we checked if the topic of the log is equal to pool created event, and in this case, we processed the pool data. And if the topic of the log was equal to the swap, then we processed it as swap data. We also verified that the log is emitted by the factory address, and in this case, the swap log is emitted by one of the pools that we have indexed. And in the helper functions, we called ctx.store.save and uploaded the entities to the database. So now that we're done, we can run the project. Let's run sqg build first. So everything looks good. Now make sure that you have Docker running. Now that Docker is up, we can run sqg up. Since we have changed the schema, we need to generate a new migration. So let's write sqg migration generate. And now we can run sqg process, and we will start indexing our data. And as you can see, we're going through at a pretty fast rate of 18,000 blocks per second. And we can also open another terminal and run sqg serve. And this will bring up a GraphQL endpoint. So let's open Chrome and test it out. Here we have all of the pools and swaps, so let's take a look at the pools first. Let's say we want to see token 0 and token 1 for each pool. And an ID. Now let's see the swaps. Let's say I want to see the IDs of them. And here we have the IDs of all of the swaps that we have indexed. So we have used the Squid SDK to build a Uniswap indexer, where we process every pool and every swap that comes from the pools that we have indexed. If you have any questions or concerns, feel free to leave them in the comments below, and also make sure to check out useful links in the video description.